Good day, everybody. We're going to go through this Unit 14 study guide so that we can review and refresh, be super confident about all of our factoring skills. So, remember that you want to factor completely. That means that some problems may have more than one step of factoring, more than one type of factoring that could be involved. So, as we begin here with question 1A, the first thing that you do for any factoring problem is look for a greatest common factor. What can you divide out of each term that is present? So in this binomial, I have a 5 and a 20 as my coefficients. Both of those have a common factor of 5. And then the x squared and the x both have a common factor of x. So we can divide that out of each. Then we do a set of parentheses for what's left over. You're trying to divide that 5x from each term. So 5x squared divided by 5x. 5 divided by 5 makes it 1. That can be an invisible coefficient. X squared divided by x. Remember, when you divide, we subtract the exponents. So this is 2 minus 1. That leaves me now with x to the invisible 1. Then positive 20 divided by 5 is a positive 4. And x divided by x, no more variables. So within those parentheses, I have a binomial, x plus 4. There's nothing else to factor within that. Here's our completely factored version. So in this b, negative 12p to the 6th plus 15p to the 9. Look at those coefficients. We got that 12 and that 15 then. These have that common factor of 3. And in fact, I see that the leading coefficient is negative. If the leading term is negative, then my GCF is negative. So I can take a negative 3 out of each of those. P to the 6 and p to the 9. Each of those have p to the 6 that we can pull out of them. Then your set of parentheses for what's left behind. Negative 12 divided by negative 3 makes positive 4. P to the 6 divided by p to the 6, those are the same. They're going to divide each other out. Now the positive 15 divided by the negative 3 makes negative 5. And p to the 9 divided by p to the 6, think subtract those exponents. 9 minus 6, this is going to make it p to the 3. So any other factoring patterns that we have looked at, they're not going to work there with a p to the 3 and then no variable. This is all we can do with it. Part C, I also see two terms. Find out, is there a greatest common factor in here? No coefficients and a 16. That's not going to have anything in common. And then I got variables, but no variables. So GCF doesn't work. What I do notice about these two terms is that m squared is a perfect square and 16 is a perfect square. I see a minus sign in between them. That is your difference of perfect squares. M squared, take the square root of that, you get an m and an m. 16, take the square root of that, it's 4 and 4. One's a plus, one's a minus. That will make sure that the middle term cancels out as you multiply when you check your answers, check your work. If you didn't see that right away, you can also rethink this as m squared plus 0m, because I'm not adding anything in the middle term, minus 16. And then when you start thinking about your factor puzzle, a times c, 1 times negative 16 for a negative 16, and then b on the bottom for a 0. Pick the two numbers, pick the two values that multiply to a negative 16 while also adding to a 0. That ends up being a positive 4 and a negative 4, which it also matches and aligns with what we just got. Then we can float right along here to that D. This one again, I see two terms in it. I notice that 49 and 100, one's an odd, one's an even, so my chances of finding those common factors are pretty limited. And I do see that 49 is a perfect square, x squared is a perfect square, and 100 is a perfect square. So that makes a difference of perfect squares. The square root of 49 is 7. The square root of x squared is x. The square root of 100 is 10. One's got to be a positive, one's got to be a negative. There's our factored format. Part E I come across also has two terms. 25 is a perfect square, w squared is a perfect square, 64 is a perfect square, m squared is a perfect square. The issue with this is this plus sign. The difference of perfect squares only works when it's a difference, only works when we had that minus sign in between them. Because there's a plus in there, I don't have any common factors. this is prime. And then over to f. I got g squared minus 14g minus 15. That trinomial, those three terms, this is where we ask ourselves, do you have a greatest common factor? No, a 1 and a 14 and a 15 don't share any common coefficient values, and there's no variable on my third term, so that won't have a coefficient either. So I start thinking about my factor puzzle, set that up. A times c up top, 1 times negative 15 makes negative 15, and then for the bottom, my b is a negative 14. So what two numbers multiply together to make negative 15 while also adding to a negative 14? Well, I'm going to think about negative 15 and positive 1. So I expand the middle term. Instead of writing that negative 14g, I now write it as negative 15g plus 1g. Keep everything else the same about this problem. Bring g squared on down, bring that negative 15 down. Split this up now into your two groups. The first two terms have a common factor of g. Divide that out from each. So g squared divided by g leaves us with g. Negative 15g divided by g, that's negative 15. Look at your second pair. Find the greatest common factor there. Between 1g and 15, it's actually just a 1 that we have in common. So 1g divided out 1 leaves a g. Negative 15 divided out by 1 leaves negative 15. At this point, you're asking yourself, do I have those matchy-matchy parentheses? Did I get them to align? Yes, we did. So that's one set of parentheses in our final answer. That's one binomial for us. The other binomial that we're looking for are those greatest common factors that we pulled out, the g and the plus 1. These are our two factors, g minus 15 and a g plus 1. You can certainly rearrange them and have the g plus 1 first, have the g minus 15 second. That part doesn't matter. Flowing on along there to problem G. Do I have a greatest common factor with these? No, we do not. So I start thinking then about my factor puzzle. So a times c, 1 times 10 puts a 10 up top, and b is going to be a positive 2 for the bottom. So numbers that multiply together to make a 10, but also add together to make a 2. So 10, I'm thinking there, what multiplies to 10? Could be a 1 and a 10, or it could be a 2 and a 5. Right? So is there a way that you can add or subtract 1 and 10 from each other to get a 2? Is there a way you can add or subtract a 2 and a 5 from each other to get a 2? No, it doesn't seem like we can do that. This turns out to be prime. I cannot find a pair of numbers that will successfully complete the factor puzzle. So it cannot be factored. Over here to H, do I have a greatest common factor? That's always the first thing that you ask yourself in a factoring problem. Is there a greatest common factor? 6x squared, negative 11x, plus 3. No common factors here. So we keep on moving into our factor puzzle. A times c up top, 6 times 3 is going to be a positive 18. B on the bottom is going to be a negative 11. So numbers that multiply together to make 18, but also add together to make negative 11. For that, we can use a negative 2 and a negative 9. 2 times 9, negative 2 times negative 9 is going to be 18. Negative 2 plus negative 9 makes negative 11. So my middle term gets expanded, gets rewritten as these two instead of negative 11x. Now it's negative 2x and negative 9x. Bring everything else along. 6x squared comes with us, plus 3 comes with us. You have 4 terms, make your groups. 6x squared minus 2x. The greatest common factor of these is 2x. That leaves behind a 3x minus 1. Look at my second two, negative 9x plus 3. They've got a common factor of 3, and even look at that. When the leading term is negative, the GCF is negative, so it's going to be a negative 3 that we can divide out of each of these. Negative 9x divided by negative 3 makes 3x. Positive 3 divided by negative 3 makes negative 1. So do you have the matching parentheses? 3x minus 1, yes, matches 3x minus 1. That's one binomial for us. The other binomial in my answer then is from the GCFs that we already pulled out, the 2x and the minus 3. Here's our factored version. Over to I, 4n squared minus 12n plus 9. Do I have a greatest common factor with these? 4 and 12, well, they've got a common 4, but the 9 doesn't have that common factor 9. No, okay. So, no common factors to divide out. We can go to our factor puzzle. So up top, I'm going to do a times c. That's 4 times positive 9 for a positive 36. On the bottom there, my b value is a negative 12. So what can I multiply together to make a positive 36, but also add together to make negative 12? Multiplies to 36, adds to negative 12. Think about it. Find that pair. Don't be afraid to make a list of numbers if you need some help picking it out, right? 36 could come from a 1 times a 36, a 2 times an 18, a 3 times a 12, a 4 times a 9, a 6 times a 6. There's lots of possibilities here, so you may need to write it down and think about it. I hope you found it. Negative 6 and negative 6 are going to be able to work for us. So expand that middle term. It's no longer negative 12n. It's now negative 6n and negative 6n. Bring everything else down along. That 4n squared comes down in front. That plus 9 comes down in the back. I'm going to group it now. Look at my first two terms. Find the greatest common factor between 4n squared and negative 6n. 2n can divide out of each of those. That leaves behind a 2n and a minus 3 when we divide. Look at my last two terms, negative 6n and plus 9. The greatest common factor that we can divide out there. A negative 6 is my leading term, so I know my GCF is going to be negative. So the 6 and the 9 have a common factor of 3. Let's see then. Negative 6n divided by negative 3 makes positive 2n. And the positive 9 divided by negative 3 makes negative 3. So look at my parentheses. Did they come out matchy-matchy? Yes, that's what we want. So 2n minus 3 is one binomial. My other binomial then, look at the GCFs, the 2n and the minus 3. Hey, that sounds a little bit familiar here. Yeah, recognize that my two binomials are the same. So 2n minus 3 is that whole quantity squared. When your two binomials repeat, when they match, you can write it out to have that squared notation in it. Now, coming right along here, we got this problem J. Do I have a greatest common factor? 6b squared plus 5b minus 4? Nah, 5's a prime. The other guys don't have that 1 or that 5 in it to work, so no greatest common factor here. So after I realize that I've got no greatest common factor there, I'm going to multiply a times c, 6 times negative 4 makes negative 24 up top. B value is a positive 5 on the bottom. So I'm thinking what multiplies to make a negative 24, but also adds together to make that 5. Again, if you need to write down your factors of 24 to help you think, 1 times 24, 2 times 12, 3 times 8, 4 times 6, lots of possibilities. And I hope you come up with, seeing 3 and 8 have that combination. We would do, let's see there, a positive 8 and a negative 3 to make those signs work. So my positive 5b is now a positive 8b with a negative 3b when we expand that into the two pieces. Bring down everything else right along with it. Bring that 6b squared down, bring that minus 4 down. Now we can group. The first two go together with a common factor of 2b. Divide that out. 6b squared divided by 2b makes 3b. Then my positive 8b divided by 2b makes positive 4. Look at the next pair, the next group. So negative 3b and negative 4, they have a 1 in common, but the leading term's negative, so let's make that a negative 1 for the GCF. And then what's left behind? Negative 3b divided by negative 1 is positive 3b. Negative 4 divided by negative 1 is positive 4. I'm hoping that if it works, my parentheses match. And yes, I see the matchy-matchy parentheses. That's what we want. So 3b plus 4 as one binomial in my response. To get that other binomial, look at the greatest common factors. That's a 2b with a minus 1. Here's our factored format. So then, letter K, 8x squared minus 10x plus 3. Does it have a greatest common factor? And no, 8 and 10 both have the even thing going on, but 3 doesn't. 8 and 10 both have the x's. 3 doesn't have a variable with it, so that's not going to work, not going to help for us there. Right, so without that greatest common factor, we're going to go ahead and start thinking about our factor puzzle. So 8 times positive 3 gives us 24 up top, and b value is a negative 10 on the bottom. So what numbers can I multiply together to make 24 while also adding together to make a negative 10? Multiplies to 24 while adding to negative 10. That's going to have to be a negative 4 and a negative 6 for us there. So my middle term gets expanded. It's now a negative 4x and a negative 6x. Bring that 8x squared along, bring that plus 3 along, and we're going to have to group them. The first two have a common factor here. I can take a 4 and divide it out of each. I can take an x and divide it out of each. That leaves us with 2x minus 1. Then my second 2, leading term is a negative, so I know my GCF is a negative. What's the common factor between the 6x and the 3? They're going to have a common factor of 3. That leaves behind a 2x and a minus 1. So looking at that 2x minus 1, it matches 2x minus 1. Matchy-matchy parentheses, that's what we want. That's how we know we're on the right track. And then my other binomial from the 4x we used as a GCF with that negative 3 we used as a GCF. Here's our factored version. Now, the last question on this front side. Always start by asking, does it have a greatest common factor? 5v squared minus 30v plus 40. Yes, we have a greatest common factor there. You can divide a 5 out of everything. So that's going to leave me with v squared minus 6v plus 8 when we divide that out. So now remember, this 5 is going to come along for the ride, not going to interfere with anything. And this trinomial that we have inside the parentheses or inside the brackets now, that's what we're going to focus our factor puzzle on. A times c is now 1 times 8. B is now my negative 6 in the middle. So numbers that multiply together to give me 8, while also adding to give me a negative 6. Adding for a positive 8, no, multiplying for a positive 8, and adding for a negative 6. That's going to be a negative 2 times a negative 4. Use that to expand the middle term. Negative 2v with negative 4v. And bring everything else down along. The v squared comes down, the plus 8 comes down, so we can group this. Look at your first two. V squared minus 2v. We've got a common factor of v. Divided out, that leaves us with v minus 2. Second two terms there, negative 4v, positive 8. I can take out a negative 4. That leaves me behind. Divided out, v minus 2. All of this still, don't forget, has that greatest common factor of 5 still carrying right along. Now, you see the matchy-matchy parentheses, so I know that's going to be my factor. And then look at the other stuff that we pulled. That's the v and the minus 4. Sometimes you will see it written here with your answer just like this, with your greatest common factor and your two sets of parentheses. Sometimes you might see it still with those extra parentheses or those extra brackets to separate it and isolate it. Either one is fine because it's all still multiplied together. All right, jumping into this m here on the back. So always the first question, do I have a greatest common factor? Look at that. 2 and 22 and 60, these are all even, and my leading term is a negative, so I can take a negative 2 out of all of them. Divide that out. Negative 2 divided by negative 2 leaves us with the 1 and then the k squared. Now positive 22k divided by negative 2 makes negative 11k, and negative 60 divided by negative 2 makes positive 30. So my negative 2 as the greatest common factor is going to come along for the ride. The trinomial inside is what we're going to use for our factor puzzle. A times c is now invisible 1 times positive 30. That's positive 30. B value is now a negative 11. So numbers that multiply together to give me positive 30, but also add together to give me a negative 11, negative 5, and negative 6 seem like they will do it. So my middle term is going to get rewritten. It's now negative 5k and negative 6k. Bring down that k squared. Bring down that positive 30. And we're going to make our groups, the first two terms, k squared and negative 5k, share a common k. Divide it out, what's left? A k minus 5. My second two terms have a common factor of 6, and the leading term's a negative, so it's going to be a negative 6 we work with. Divide that out. This is k, and then 30 divided by negative 6 makes negative 5. Don't forget, there's still that negative 2 greatest common factor. You didn't lose it, did you? I sure hope not. So negative 2 GCF is still going to be in my final answer. The matchy-matchy parentheses give me in my next binomial k minus 5. And then lastly, the GCFs that we pulled out in the process, the k and the negative 6, make our second binomial for us in that setup. Here we are. Now n. Do you have a greatest common factor to start? Look for it, search for it. Yes, we do. We've got a 4v squared as the greatest common factor in here. There's a lot happening. This leaves us behind v squared minus v minus, sorry, I apologize. Negative 8 divided by 4 is going to be negative 2 with no more variables. So I can factor this part. 4v squared as the GCF carries on along. Do that factor puzzle for our trinomial. I got 1 times negative 2 gives me a times c negative 2. Then negative 1 is my sum number. So multiplies to negative 2 while also adding to negative 1. And that's going to be a negative 2 with a positive 1 then. Rewrite that middle term, right? You know you were thinking about that invisible negative 1. It's now negative 2v with positive 1v. Bring down everything else. V squared comes along, negative 2 comes along. So my greatest common factor, 4v squared, is still here with us, and we're ready to group. V squared minus 2v, share a common factor of v. Divide it out, what's left? V squared divided by v is v. Negative 2v divided by v is negative 2. That positive 1v and the negative 2, well, they've got a common factor of 1. Nothing else much. What's that leave us with? V minus 2. So the greatest common factor, 4v squared, is still happening. The matchy-matchy parentheses give us a binomial in my factored form. And then I look at my GCF that I pulled v, look at my GCF that I pulled positive 1. Here's the factored version. This is completely factored for us. And part O then. First question, let me hear it. Do you have a greatest common factor? That's always what we're going to be asking, always where we're starting. So 3n to the 5th minus 6n to the 4th minus 72n to the 3rd. We've got a greatest common factor here of 3n to the 3rd. Divide it out. Let's see what's left over. That's going to be n squared minus 2n minus 24. So 3n to the 3rd comes along as the GCF. Make your factor puzzle based on that trinomial. A times c is my 1 times negative 24. B value is my negative 2. What do I multiply together to make a negative 24? While I can still add it together to make a negative 2. That would be a negative 6 with a positive 4. Rewrite the middle term. Negative 6n plus 4n. And bring along that n squared in the front. Bring along that minus 24 in the back. You're ready to group. 4 terms that are going to group together. Find your greatest common factor here. I can take an n out. That divides and leaves an n minus 6. Second pair, 4n and negative 24. Greatest common factor here is a positive 4. Divide that out. I'm leaving n and negative 6 behind. And I hope that you did not leave your greatest common factor behind. You remember about that 3n to the 3rd? It's still part of the problem. So with a greatest common factor, 3n to the third. And a set of matchy-matchy parentheses, n minus 6 is a factor. Then I've also got a factor with my GCFs n plus 4. There we are, completely factored in all its glory. So question number 2 wants you to do some division for us. Now, when I divide by a monomial, remember that's where each piece of the numerator gets a turn in the division. When you divide by the binomial in the denominator here, you got to think a little bit differently. We've got to find out if that numerator is capable of being factored. So, to look at factoring my numerator, I'm thinking about 1 times negative 20. That's negative 20. My b value on the bottom is positive 8. What do we multiply together to make negative 20 while also adding to make positive 8? Multiplies to negative 20 while adding to positive 8. How about positive 10 with negative 2? That should do it. So we're going to go ahead and rewrite then. My middle term is positive 10b minus 2b, but I still keep the b squared from up front. I still keep that minus 20 from in the back, and I make those groups. What do I have? My first two, b squared plus 10b, have a common factor of b. That leaves behind b plus 10. My second two in that next group, negative 2b minus 20. The leading term is negative, so my GCF is negative, and I got a 2 I can divide out of each of those. So negative 2b divided by negative 2 is b. Negative 20 divided by negative 2 is positive 10. So with that matchy-matchy set of parentheses, I've got one factor. Then you find the other factor, the other binomial, based on those GCFs, the b and the minus 2. Now remember, we weren't factoring this just a factor. No, there was a purpose. This is my numerator, b plus 10 and b minus 2. It's all divided by b minus 2. Why does this help me? Well, remember, anything divided by itself divides out to a 1. So what are we left with? b plus 10. There you go. Short, sweet, and simple. So problem 2b also wants me to do some division. It's got a binomial in the denominator, so I have to see if I can factor that numerator. So we'll take it and set it up in a factor puzzle. 1 times negative 28 is negative 28 for my 8 times c up top. B is the negative 3 to go into the bottom then. So numbers that I can multiply together to make a negative 28, but also add together to make a negative 3, that's going to be a negative 7 with a positive 4. So I rewrite my middle term. It's now negative 7d plus 4d, and still keep bringing along that d squared from the front, bring that negative 28 from the back. Group them together, d squared minus 7d. I get a d, divide it out, d minus 7 is left. Second two terms, positive 4d minus 28. What's that greatest common factor? I've got a positive 4. I can divide out each of those, and that's going to leave me with a d and a minus 7. So the part that you're all looking for, the matchy-matchy parentheses, d minus 7. And then what else do you have? The d that we pulled as a factor and the positive 4 we pulled as a common factor. Again, we didn't factor just to factor. We had a purpose for this. D minus 7 and d plus 4 are my two binomials that are now dividing by d minus 7. And when I divide, if I have the same factor dividing by itself, it cancels out to a factor of 1. D plus 4 is all that remains. And then number 3, factor this polynomial completely and then circle all of the required factors from the table. Do you have a greatest common factor? It's the question you ask yourself every single time you start. Do you have a greatest common factor? Yes, we do. I can divide a 3 out of each of these terms. So what does that leave behind? 2x squared from 6 divided by 3 is 2. Positive 33x divided by 3 is positive 11x. And then positive 36 divided by 3 is positive 12. So I'm looking at the trinomial inside of my parentheses, or inside of my brackets, however you write them. That's going to set up my factor puzzle. So 2 times 12 is a positive 24 up top for my A times C. Positive 11 then is my bottom value. What numbers can I multiply together to make a 24 while also adding together to make an 11? So that's going to be a positive 8 and a positive 3. Rewrite that middle term then. It's now a positive 8x and a positive 3x for us. Bring along the 2x squared as your first term. Bring along the 2x squared as your first term. Bring along the positive 12 as your last term. And bring along that greatest common factor of 3. So then we're going to get them into some groups. My first pair have a common factor of 2x. Divide that out, it leaves us with x plus 4. My second pair have a common factor of positive 3. Divide that out. I'm left with x plus 4. And we still have, yes, it's still got a greatest common factor of 3 tagging along. So you see those matchy-matchy parentheses in there now, right? So the x plus 4 and the x plus 4 are going to be one set of parentheses in my answer. And then greatest common factor that we pulled 2x, along with greatest common factor that we pulled plus 3, makes the other set of parentheses, and greatest common factor of 3 was involved. So there are 1, 2, 3 things being multiplied together here in this completely factored form. So there should be 1, 2, 3 things that we circle in our answer. Greatest common factor of 3 needs to be included. The binomial of x plus 4 needs to be included. And lastly, the binomial of 2x plus 3 needs to be included in our response. I hope that you are feeling so much more comfortable and confident with all of your factoring. Always remember to start with, is there a greatest common factor? Look for your difference of perfect squares and think about your factor puzzles. Don't be afraid to use your calculator to help you with those integer rules when you need. And I hope you have lots of luck on your test.